Do you have any idea of what light is? We know that with our eyes, we can see different objects. We can see the light from the sun. We can see light from a source uh, of light energy, you could say. But we also know that sometimes over the years, sometimes our eyes either don't see as well. Second, we also know that sometimes people don't see all the colors. But can we also use light to better understand the physical world? And this is the first video here on a series about optics. So let's see what we can learn here. So when you think of light, the first thing we can think about is about our eyes. Our eyes are biological pieces of equipment, you could say, that are fine-tuned to receive information, magnetic information that our eyes are accepting. They are also, how can I say that? They are interpreting and they're sending it to our brain. And our brain are looking at the information, the input, and can tell us what is the object, the color, and so on. So this is something that we grow throughout our lives. We gather more data. We know better what it is. But what is this light? What kind of energy it is? So let's see if we can talk about it a little bit more. So I have here, there we go. Excellent. So this is what we call the electromagnetic spectrum of light. Let's see if I can put the link into here into the chat section. If you're listening to this, watching this video in replay, the link will be in the comments below. So here what we have, it just shows that we have basically a visible light right here. So that means that we have our eyes that can see red colors. We have yellow, green, blue, and purple. So you can see this is a very small bits on what the whole spectrum of electromagnetic energy. So here, this is what we call visible light. So that means that when we think of electromagnetic waves, it's much more than that. However, our eyes are specialized to be able to see those only. So let's see if we can explore that a little bit. If you have visible light, they're made by light bulbs, for example. We also have visible light coming from the sun. Now, we also have different kind of energy considered as part of the electromagnetic wave. First of all, we can go, so if we have wavelengths, so here the wavelengths of visible light are 10 to the power of -6 meters, so like a millimeter in length or so, between 0.4 and 0.7 millimeters. So what is interesting is that those waves can actually get longer and longer. So if we have longer waves from the visible spectrum of light, we have what we call the infrared section. Infrared light we cannot see with our eyes. However, we can feel it. If we're close to a fire, we can feel the heat coming towards us. So these are longer wavelengths. So here for the infrared, we have at the 10 to the power of -5. So here we have a few centimeters in length. Now, interestingly enough, we have here different sources. So we have a heat source. If you get shorter wavelengths compared to the visible wavelengths, we have what we call ultraviolet. Now, the ultraviolet wavelengths are much shorter. We cannot see them with our eyes. However, if we go into the sun, sometimes we can feel it on our skin. We can feel the heat from the sun as infrared energy. However, the UV, often the way I see it is that when the sun comes to your skin, and it's like just like needle poking on your skin. So there's a reaction there, much shorter. So what happens is that they can make some molecule vibrate. So here the wavelengths are 10 to the power of -8. So what happens is that much shorter wavelengths, that means that molecules are affected by those wavelengths. And that's why if you go to the light with too much UV light on your skin, the molecules are vibrating, they break down, and therefore we have mutations in our DNA. And what happens? We can have a skin cancer. So we have to be careful. Now, if we get the wavelengths shorter and shorter and shorter again, then we can affect a much smaller matter. So here it goes to, we can affect the atoms and we can affect the nuclei. Now here we have X-rays and gamma rays. Now if you think of X-rays, X-rays can be used if you go to the dentist. So let's see. So here's an example. So this picture here is from here a person from Dutchland, and here it's their own picture. I'm going to put the link in the comments once I edit the video. And what is interesting here is you could see the density of the matter can change. So here you could see we have some a tooth that has been repaired. The ceramic used is much denser than our teeth, and that's why the X-rays don't traverse them. And you could see in the root, we can see here the root of the tooth, and here we could see the person had a root canal. So here the wavelengths are much smaller, much higher energy. Too much X-ray is not good for us because it affects atoms, and then it could create also difficulties with our DNA and mutations. Now on planet Earth, we are protected from the X-rays from the sun, for example, because we have our atmosphere, and the molecules in the atmospheres, the molecules are absorbing the X-ray wavelengths, which is good for us. So now if you go and make the wavelengths a bit longer and longer, so we're going through the infrared. So now we go into what we called microwave. So the microwave here, so here we have radar, and we use those to see energy coming from our space. So here you could see that we have wavelengths of 10 to the power of -1 to 10 to the power of -2. So here we have 0.1 meter, so wavelengths about this big here. And the reason why those microwave need such a big radar dish is because waves are getting bigger and bigger the further they get away from a star. So let's see if I can show you. So for example, if you have a star right here, the star is sending waves of energy like this. So that means that if we have our planet that is right here, let's see, this is Earth, we are receiving wavelengths from our star. However, if you are looking for information from a distant star, then we have those waves that are getting longer and longer. So what happens is that if our Earth is at so many light years, tens of thousands of light years, then the wavelengths is much bigger. And this is one of the field of research I love in astrophysics. So here's an example where we have a satellite dish that is being used to collect data from far stars. Now, in the last few years and decades, more and more of these have been created. So here, this is about 50 meters in diameter. However, it has a weight, and we have to find a way to, there's a limit to the structural integrity of these. One of the best project I like, it's called the FAST project. It is a satellite dish that is in China. So what they did here to make it as big as they could, they actually have a suspended dish between mountains. So here the FAST project, called FAST, is in China. And here the diameter is about 500 meters in diameter. So that means that we can see much larger wavelengths. That means that we can see stars and information from stars coming from further and further away, especially people interested in knowing about stars, but also the origin of the universe. And that's beautiful this way. So here we have So this is a picture from Rodrigo con Laje, and it was done in 2020. That's a project that is not very old. So if some of you, sometimes they can teach, they can speak in English, but also in Mandarin, excellent opportunity for you to work with them. Outstanding possibilities. Excellent. So let's see if we can go back to my, perfect. So here, interestingly enough, so we have microwave, then we go into the radio wave. So the big dish I showed you with the fast, for example, you have radio waves that are longer and longer. And here we have all the way to AM radio waves. So here these waves are 100 meters, 1,000 meters in length, much bigger. So we need bigger and bigger radio telescopes to do that. Now, I noticed that there's also some projects around the world. Sometimes you can use, there's a few projects where people were using satellite dish of different individual. Because keep in mind that if you are part of a city and you have 1,000 people with the satellite dishes pointed in the same direction, why can't we take all these satellite dish and use them to receive information from space at a diameter of a kilometer or even more? This is quite exciting, and with the internet, that's getting more and more possible. Perfect. So this is the electromagnetic waves. So the electromagnetic spectrum of all the sources of energy. I remind you that the visible light is only a small portion of what the electromagnetic wave or spectrum is, but by learning how visible light works with our eyes, we can better understand every other types of waves, and that is why we are studying optics in grade 10 in science. If you've enjoyed this video, please do not hesitate to subscribe to our channel. I bring in some videos about science weekly. I'm here to answer your question above all. If it happens you have any clarification questions, don't hesitate to put them in the comments below. In the meantime, my name is Alain Faber. I've been teaching science for more than 25 years. I'm here to share what I know and also do science with you. So at this point, I'm going to link you to another video that you will enjoy so that we can do more science together.